To introduce Florian Audet, who is a psychiatrist, meta-researcher, professor at the University of Rennes, a member of the steering committee of the Laurier program, and a leader in the field of research integrity, reproducibility, and did a lot of work on data sharing. And so today is going to do two presentations. The first one is dedicated to concept of reproducibility and replicability.
Okay, thank you very much, Isabelle. So I'm so glad to speak to all of you there. For various reasons, I had a few time to prepare all those talks. So some slides, perhaps some of you already saw the slides, know the jokes, but I will try to make sure that you will laugh again with the jokes. Some jokes are new, of course. My goal is that when you leave, so my goal, all our goal with this workshop, is that you can leave very smarter after all the talks. And I have two options. So either give a talk, this is a difficult option, or the easy option is to put Mozart and to make you listen Mozart. So you might know the Mozart effect or not, but this is super famous because I used to speak about reproducibility, and once I was going to Brest. Brest is in the west of France, so nobody goes there, in general. Reproducibility, meaning that I'm not a big expert, I'm a small expert. So I was going there, and in the car, I was listening to the radio, because you can go to Brest by car. And on the radio, there was this guy speaking about science, and he said, so the Mozart effect is super cool, because actually it's a paper published in the good journal Nature. That means that when young kids listen to Mozart, then they can perform better on QE test, IQ test. So they are smarter. So there is no Mozart effect for English. But he said that, and then he said, okay, but I must say that's super, very interesting and super cool, but I must say that it has never been reproduced at all. People tried, but it has never been reproduced. Still, we spoke about this on the radio, and this. And I will take this quote by Richard Horton, who said, the case against science is straightforward. Much of the scientific literature, perhaps half, maybe. That's why people start to think about the problem of reproducibility, because if it's untrue, it won't be reproducible. Although sometimes things that are untrue are very reproducible. But the question is, what does research reproducibility mean? Because when we start to speak about that with colleagues and fellow researchers, many have very different definitions. And perhaps the definition that I will use today, that were those that are not shared by anybody to take this paper, and I will illustrate it with a case study. So my case study is my old one, the sapin Noël à la meringue, the meringue Christmas tree. So actually, this is a super good pastry. It's super great for Christmas. It's joyful, and so on. So you can cherry pick a recipe on. You took the recipe. It's like exactly like reviewed like so sorry Rolly, but it's like plus biology, because you start by the result and then you have the method at the end. So I don't know why, but it's like that. So you have the result, and then you have the method, the recipe, how to cook the little Christmas tree meringue. And each recipe is one step that you need to address to get the recipe done. And actually, at each step, there are like what we called the cook degree of freedom, because you have some degrees of freedom. So having all those details for somebody to be able to reproduce, either in theory or in practice, the recipe, this is called method reproducibility. We can reproduce the method. We can do exactly the same thing. And then we have degrees of freedom, meaning that I can use different tools. I can take different time to do the recipe. I can use different sugar, different eggs, can use different forms for the trees. So I have 80 48 possibilities just like that. These are the degrees of freedom. Then you cherry pick one pathway among all those degrees of freedom, and you get the result. So this is the result. So this is a true experience. So these are my. So obviously it's because of the recipe. So we'll say that. So this is called result reproducibility. You do exactly the same thing that is written in the paper, or you try to do it, and then you get the result, and you look if the result is reproduced. So it's also called replicability somewhere else, result reproducibility. And then there is another dimension. This is inferential reproducibility, meaning the conclusion. You reach the same conclusion. So actually, the inferential reproducibility is good because you all reach the same conclusion that it was not beautiful, it was bad. It is going to trash as many experiments, and you'll never see those Christmas tree again. And actually, I will show you rather this that I did for our Christmas. Actually, it's a cake that was very enjoyed in the family. But I won't tell you the recipe, as many scientific experiments. So I have no specific conflict of interest, ever with big meringue, ever with big pharma. I have been funded by Metrics, so Laura and John Foundation, when I did my postdoctoral fellowship at Metrics. And this is super important because people are speaking about reproducibility crisis. And I think that one of the major reasons for the reproducibility crisis is, for instance, this paper that triggered a lot of things. This is one of the most read papers in the scientific literature because if you look at the metrics, it got a lot of citation, but 3 billion views, so 3 million views. Okay, so people viewed it 3 million times. This paper is called "Why Most Published Research Findings Are False?" And actually, it was true because after so many views, somebody found an error in the formula, in the correction. But after 3 million people saw it, actually. And Metrics, the center, is funded by Laura and John Arnold Foundation. And I think that if we are also talking so many about the reproducibility crisis at this time, it's because there is many research funded actually by Laura and John Arnold Foundation. So for instance, this one on psychology, where they try to reproduce 100 of experiments in the field of psychology to estimate if we can replicate their results. And I think the slide speaks by itself. On the left side of the slide, you have the original studies and replications in terms of p-values. And on the right side, you have the original studies and replications in terms of effect size. So you have various research projects that have been funded. You have one, we talked about that yesterday, in cancer biology. And one of the problems was the problem of method reproducibility because it was super difficult to implement the exact method. So that's why Nature, again, the same that published the Mozart effect, is their reproducibility crisis, a super paper. But what I find super important in this paper, it's not the result, but this is the quote. The quote, it is reproducibility, it's like brushing your teeth. Once you learn it, it becomes an habit. And so I know that because I have colleagues that are dentists here. And actually, I learned the basic of research reproducibility when I went to my dentist. And he said, Florian, you don't know how to brush your teeth. And then he tried to come with all his tools in my mouth, and it was a slaughter. So actually, reproducibility is like that. It's not a simple thing that you should do. And if you can do it, it could go well. And if you don't do it, it could be bad. And actually, I would like to thank Marcus for writing this paper, because I will make my entire career on this paper by giving examples and using it and teaching a lot of things to people with this, because it's super smart and super brilliant. So you'll tell me if I say it right. I'm not sure. But this is like the hypothetico-deductive reasoning that we are used to have, at least when we are doing quantitative research and perhaps sometimes in qualitative research too. they will be a little bit, they will disagree a little bit, but let's say, first we generate and we specify hypotheses. So we have to make a good hypothesis, and sometimes it's super difficult to do. It's the most difficult step, perhaps, because you have to understand all the literature and so on. Then you have to design the study. Then you have to conduct the study exactly as you design the study. Then you have to analyze the data, to test the hypothesis, to interpret the results, and then to publish. And with what you have published, others will build a new research question. So actually, this is super important. And in red, as you can see, at each step, there can be problems. So I will start by illustrating problems, and then I will give some kind of solutions that have been envisioned. So to illustrate, I will take this paper. I'm a psychiatrist, and a few years ago in Molecular Psychiatry, which is a very, very famous journal for us psychiatrists, they published this paper about synodic lunar phases and suicide, meaning that during a full moon, people can kill themselves because of the full moon. So they found an association that is of interest because you just have to stay at home during the full moon. So it was in premenopausal women in northern Finland. So first of all, generate and specify hypotheses. So if they have done a serious literature review, they should have shown that since 1985, people are pretty aware that moons have nothing to deal with mental health, or at a small, very small point. So actually, it goes very against the current consensus. So when something goes against the consensus, it can be that the consensus is wrong, totally wrong, but it can be also that the priors are very weak. And if priors are very weak, we can face some problems at some point. Then you have a lot of problems. So we talk a lot about low statistical power. We talk, and I will give you other example of p-hacking, meaning you repeat statistical analysis until you have a p-value that you are happy with it, and arcing, making the hypothesis after the results are known. So actually, in this study, it seems that it was possible to make 48 possible subgroups. This is a correspondence that happened to 2 gender, 2 age groups, 4 seasons, 3 moon phase. So you have actually a lot of degrees of freedom in the statistical analysis. So they said the colleagues who performed post-publication peer review, they said that they had the impression that the study was driven by an exploratory post-hoc search, and that all the, let's say, hypothesis behind the studies was done a posteriori and not a priori. So they tried to replicate it from a sample in Australia, and they found no association at all. But of course, the answer is here. So unexpected results are difficult to be accepted. And perhaps they also say it does not apply because we are in Northern Finland and you are in Australia, and this is different regarding exposure to sun. And of course, sun and moon are like 2 good friends, and you cannot take account one without the other. And at the end of the day, it took much time to replicate the finding, to try to replicate the finding, this time in Sweden, and to find almost nothing. So here again, poor quality control. So this is a problem. I tried to find a new example for that I never spoke about. So this is a study, effect of low laser therapy in autism spectrum disorder, that was conducted actually in Israel, that included patients in Cuba. So first of all, it's a little bit far, and it's curious to have this kind of study. So now I will let you work a little bit. This is what you can find. Oh, no, problem. So I will do it because the solution is here, so you won't see the solution, or here perhaps. But just if you look at the data that are posted on clinicaltrial.gov, which is unusual, but sometimes it happens. You can see 21 patients here, 19 patients here, and here you have mean standard deviation. This is about an outcome that is a change, a pre-post change in patients that are selected based on the score on the scale. So when you select patients based on the score, high score on the scale, you will expect regression to the mean at some point, especially in the placebo group. No regression to the mean, very low standard deviation. So you can be very, very suspicious about what happens in the control group for this trial. So actually, you can look at the published trial. This is funny because you have the global score of the primary outcome that is shown here. And now you have the subscale score at baseline that is shown here. Oh, it's exactly the same. So basically, all other subscores should be zero but not. They are not zero. And you can look at that. You can look again. Here you have a pre-score, post-score in the placebo group. Almost no change in the placebo group. So this is super suspicious because you have too much consistency across groups. No change between before and after. So actually, you can ask the data. And actually, with my colleague Dorothy Bishop, we asked the data. And actually, we got the data. So this is the data in the intervention group. So it looks like perhaps genuine data, or at least not that bad. And this is what we can see on the aggregated data. But I will be very much more interested in data in the, let's say, in the placebo group. And here is the placebo group. So as you can see in red, you have patients that have exactly the same data each and every day on a given scale, which is very, very unlikely. So I cannot say that those are fraudulent results, but I can say that there is likely a problem of quality control in this study. So perhaps the primary investigator has a dog who eats the touch of the computer. So this is it. So another example, because this is when you have the data, sometimes we don't have the data that we want to do. So this is an example from Rennes, my university. So I won't be long to explain the science, but these are two researchers that claim that they have found the cause of dyslexia, which is super important because it can be corrected. Those are researchers from physics. There are many problems with the study. Elizabeth here knows this study well too. Actually, they come from Laboratoire d'électronique quantique and chiralité. This is a laboratory of quantic electronic and chirality. So perhaps you saw that in Men in Black or in some films like that. But actually, there is, the mail address here. So you can have a look on Google Scholar how it looks like, because you can be very curious. So it looks like that. This is what is written in the paper. So it says that it has been approved. So not in the paper. In the paper, it's not written, but it's written in supplementary material. It said that it has been approved by the research board at Rennes University. So I won't show you how it looks like an institutional research board at Rennes University, because there is no institutional research board. And actually, we don't even know if the patients were really dyslexic at some point in this study. So a bad study like that, but it received considerable attention with, not that much citation, but a lot of media coverage. He received a prize of the Academy of Medicine because it was a study that claimed that they found a cause for dyslexia, which is super important. They had 9 patent citations. It gave rise to glasses. So this is almost 400 euros, and lamps that are sold. And actually, there has been a clinical trial. One of the lamps, it's not published. One of the glasses is not published. So now we have also independent studies that are coming that are negative, but it took time. So this is a problem of things that get not published, and sometimes it's very problematic. So these are the antidepressant trials. I'm a psychiatrist. So above the line, the positive antidepressant trials. Below the negative antidepressant trial. So you should say, wow, antidepressant is super cool. But this is in the published literature. And this, this is what FDA had. So published literature, what FDA had. Published literature, what the FDA had. So you say, okay, but this is a matter of problems with the industry. I would say, no, this is what happens in a hospital. We try to monitor what is published in the hospital. So we automatically check with the French Open Science Monitor, and we found that 11% of studies that were completed and due were actually published. We manually checked because there was a lot of false negative, and we found that this number was 40%. So we published 40% of the studies that are due. Actually, this could be easily improved because the problem is that it was not detected by clinicaltrial.gov because people didn't know that they should put the registration number in the abstract to be automatically indexed. And this is exactly the same, so it's not in Rennes Hospital, it's almost the same in many other sponsors. So, okay, so what are the solutions? I think I will be on time, but I need to speed. The solution is to so ask a good research question, so perform even a good systematic review of your research question and of the field before you do the research. It will help you also to see if there are ongoing efforts on the question, because we don't need to duplicate efforts. Of course, we need to adapt the best strategy for designing studies. Registration might help in order to make sure that people are not p-hacking, because you can check. So in order to answer to one question this morning, pre-registration does not, you can still do exploratory research with pre-registration. You register what you want to do, and then you say, I didn't do what I wanted to do. But it makes you, it makes it clear that it is exploratory. And one of the problems is that, like for suicide and full moon, people didn't say that it was exploratory. So actually, if all of you don't have an account on the Open Science Framework, maybe you could create one, and it will be a good take-home thing to do after this conference. So another thing is good, because to avoid low sample size, we can think in doing a large project with colleagues, so large prospective replication effort, and the field of psychology did this very nicely. And in order to avoid publication bias, we should commit to try to publish all the things that we have done that matters, because there are some studies that would be better not published, but when the study is done seriously, of course, it should be published, whatever the result is. And you have a lot of tools that are, so we discussed tripod this morning, but there are so many more for many clinical trial design that you can, and I will demonstrate you in the next talk that they are ready for everything that you want a guideline. And actually, you can go on the Equator network and have a look at that. And perhaps also, because you are all here, you are listening, when you will be back in your team and unit, you can show all these tools to your colleagues. And part of the program Laurier is to have a group of ambassadors. So I think Philippe will discuss this, and Isabelle also. But people that are able to spread the use of all these tools to all the colleagues, to say, oh, it's fun, actually, you can use it, and how to navigate in that. Because it's not so easy to navigate in Equator Network, because there are so many guidelines that sometimes it's quite difficult to find the good one. But people who are used to it can help you. And in order to avoid making hypotheses after the results are known, in order to avoid publication bias and many things, there is this concept that we discussed this morning, the concept of registered report, where you can develop your idea, design the study, and the study is accepted in principle based on the importance of the research question and the quality of the study design in order to answer the research question. Then you can collect the data, analyze the data, and then you can write the report. And if you done properly what you have promised to do, actually, it will be accepted, whatever the result is. But as Rolly said, sometimes it's not so easy, because it takes time. Sometimes there are a lot of things that are not planned. And this can be also discussed with the editor. And then you publish the report. So I was saying that this is a solution, but as meta-researcher, we still have to look if the solution is correctly implemented. So we had an interest on, so this is what we done with Nora. We are very interested to see if there were clinical trials published as registered reports. So back in a few years ago, the Lancet had some kind of theory that was not exactly a registered report, but that looked like a registered report. But we wanted to see if now people are using this to publish clinical trials. And we thought that actually we would found very little studies published as a registered report. But actually we found a lot published in the same journal group, that is a Journal of Medical Internal Research. And they have a specific number that's called IRID, a registered report identification number, that they give to a lot of papers. And it's curious because there is a number of registered reports. It's not directly described as a registered report, but they claim that it's a registered report in some occasions. So it's quite curious. And when we looked at all those clinical trials, we looked at this is a date of inclusion of the first patient in the clinical trial, so the black line. In orange, you have registration of the study. So you can see that for a lot of studies, registration occurred at the time of inclusion of the first patient or before. But in a few studies, registration even was posterior to inclusion of the first patient. And then registered report, there was no real registered report. It was rather than a study with a published protocol. And the published protocol arrived, this is in blue, was published often very much after inclusion of the first patient. Meaning that all the good things that you can have by reviewing the protocol before doing the study was not done for this kind of study. So I think it's important to look at the solutions and to look at how those solutions are implemented. So I'm nearly finished. So data sharing, and this is a famous quote from the editor of the New England Journal of Medicine, that people that share data and reuse data, like those who reuse data, are research parasites. So we were not very happy in the community. So some of the community created the Parasite Award to reward people who reuse data from the others, but they also create the Symbiont Award to reward people who are sharing the data, meaning that we need to have a specific system to give an incentive to those practices if we want them to be done correctly. And there are many declarations, including the Hong Kong principle, that basically say that. There are many at this time, many opportunities, many organizations that are starting to be in that field. So Laurier here is one at Inserm, but you have the UK RN, and I'm sure that Marcus will speak about it. We have Quest, so we spoke about it yesterday. So you have many things. And as part of Laurier, we have a website, so you can go on the website. We have some groups that are going to be started, so some on reproducibility, some on meta-research. And actually, if you are interested and you want to get smarter, you have two solutions. You can either listen to Mozart or go to the Laurier website and to register. And you can still do it from now, because we will need a lot of your help. And actually, it will be even better if we can help you instead of us helping you. So actually, we need to collaborate, and you are all welcome in that. So thank you very much.
Thank you very much, Florian, for this great presentation, as usual. Any question? Perhaps I will start with the registered report. So, some people present registered report as a solution. But for example, for studies like clinical trials where you have a huge delay between the protocol and the results, and a lot of things that can happen that will really impact the trust you will have in the study, do you think it's a good format? Or anyway, in clinical trials, we know that there is a protocol and we just want people to give us access to the protocol?
So I think the importance for clinical trial will be peer reviewing the trial before its conduct and making it transparent. Because actually there is a lot of peer review that happens before a trial. You have a peer review at the funding body. But for instance, here we have the PHRC, but this peer review, only the expert in the PHRC know what is there inside, and even the people who are reviewed are not mandated to make the change that are asked. So it could make that apparent. So ethical boards also do some kind of peer review, but sometimes it's insufficient from the methodological point of view. It's rather focused on safety. But I think it could. First, make it transparent and make it available. So it could improve quality. So it already happens. So the simple thing would be to make it happen in this process. So actually, not a big change. Second, it will perhaps helps to save time also to people, because if one peer review is known, the referee in a second organization, like the ethical body, can have a look at what I've said the first peer reviewer. So it will also save time. So I think there is some room. But for journal, it's difficult. Lancet gave up, and mostly because it takes time to run the trial. And between the time they accepted in principle, medicine changed a lot, and the study finding was perhaps less impressive, or perhaps even less useful at all. So I think it was a big force being their decision to stop it.
I think another approach is also that some journals, and I think, for example, the Journal of Clinical Epidemiology is doing that, is endorsing open science and saying that they request the protocol posted on Open Science Framework or another platform before the study is started. Yeah. And that's part of their request and question for peer reviewer to check.
Yeah, exactly. But I have another thing for early career researchers that are in a PhD. Sometimes the time frame for the PhD is not sufficient to do a registered report. And so this is something that is new, and as a new early career researcher, sometimes it's very good to use it, but just be aware that you are able to do it when you start this process.
Philippe?
Great talk, Florian. All people are trying to assess the risk of bias of studies after the study is finished. Yeah. Do you think that it would be useful to do that before beginning the study? Because my feeling is that nobody wants to perform a study that would be considered as at risk of bias at the end. Therefore, perhaps we could help people by working on tools to evaluate the risk of bias based on the protocol at the beginning, and to help to modify the protocol.
Yeah, I fully agree, because as it was written in Nature, it's like brushing your teeth. So it's a lot of small things that are, perhaps some, can be easy to correct from the beginning. And it's at this place that we have to correct the things.
So it's not really a question, it's more a comment. So I work on the nanobubbles project. We're doing the first replication studies in nanoscience. And we did a pre-registration or registered report. And it was a bit overwhelming because I feel like some templates don't really fit all fields. So we're doing with PCI-RR, and we had to change twice. They have a table that you need to fill up. It's a bit overwhelming. I mean, it's good to do, but yeah, maybe at first it's a bit difficult. So maybe, I don't know, I think with the OSF, they have the option where you can kind of tailor it to your needs. Not at least what we went for, but this is for anyone that's thinking about doing it.
Yeah, but you said everything. So, and actually, the OSF can be flexible. So you can use a template, or you can use a free registration if it is needed, because sometimes we need to adapt, of course.
Hi. 2 short questions here. Do you have any tips about teaching reproducibility, in the sense that, for example, we conducted a focus group in Croatia about how people perceive and understand reproducibility in contrast to replicability and repeatability, and we found like a lot of confusion between those terms, like people either confusing one for another or just not understanding the difference at all? And the second question is something you touched upon lightly. How might these concepts work in qualitative research, where kind of reproducibility might be a bit more finicky in the sense of the inferences?
Yeah, this is not my field, so it's more difficult for qualitative research. But I would say that at least method reproducibility can be achieved in qualitative research. And this is something we discuss with my colleagues that are not aware of reproducibility, that are heavily involved in qualitative research, and they first simply say that reproducibility means nothing to them. And then when I discuss and show example, they say, oh, but some of these examples may apply for us. And actually, for method reproducibility, it really applies. So I think that it could be adapted a little bit. And of course, you are not in the hypothetico-deductive model, but you are more in an inductive model. So it's quite different in terms of meaning. But there are some analogies that can be useful. And for teaching reproducibility, so I will give you metric at the next talk, because we try to teach reproducibility to a large public. So it's not so easy to discuss reproducibility with the public, because either they can be frightened when they saw the glasses for dyslexia, they can be frightened and run, or you can be also very negative, like science is broken, very negative narratives or something like that. And this is not the term. Actually, science can be better, but actually science does well in some occasions. So it's very good to be positive on that. So I will tell you this, but the talk after. And I will give you my secret.
Okay, thank you very much, Florian.